Welcome back to the channel. It's been a long time since I last uploaded my video and I am extremely sorry for that I was not consistent about providing you the lectures that I have promised. Actually I had a lot of works to do, that's why I was not consistent, but from now on I will try my best to provide you the playlist of Java that I have promised to give. So in this session I'm going to teach you the data types in Java. So what are the data types? A data type defines the type of data a variable can hold, such as integer, floating point, character or boolean values. So what does this mean even? In our previous example of code where we have written some simple programs, there we have created our variables storing our integer values, means the value numbers that that doesn't have any decimal point. Those values are integers. We have created our variables, stored our integer values into that variable, but we have typed something, the data type, before the variable that was int. That what does this mean? It tells the compiler about about what kind of data that can be stored on that variable. So suppose that we want to store floating point numbers into that variable, so what will happen then? Actually, when we are defining our variable as integers, we cannot store the floating point numbers. If we try to store floating point numbers, then something will happen. The part after the decimal point will be eradicated or ignored by the compiler, and only the part before the decimal point, the integer part, will only be accepted by the compiler. So suppose that we are working with critical systems where every decimal point is important. It's like scientific research. In such kind of scenarios, we have to have the knowledge about the data type and the characters. Suppose we want to store some single characters like A, B, C, whatever else, only single characters. Then we have to define our variable as char or boolean value. Suppose we want to define something that it may be true or it may be false, then we have to define it at boolean values. A data type in Java tells the compiler what kind of data a variable can store. As I have previously discussed, how much memory should be allocated for the data and why it is needed. Suppose that you want to store a small amount of data, means a small number 1 to 100, and you are sure about that's the limit of this number cannot exceed 100 till the end of this universe. So, and you are using a data type that is holding a large amount of memory, and just storing a small amount of number, you are using huge amount of memory, and it is not the proper utilization of our resource. Memory is one of the most valuable resource. So we have to have the knowledge of data type and how much memory it is consuming. Then what operations can be performed on the data. Suppose that you have created two variables and the data type is integer, so you will store two numbers. You can do any kind of arithmetic operations upon those variables, like all your data, like addition, subtraction, multiplication. You can find you can use the modulo operator upon them. But suppose that you have created two variables storing characters and you have defined the data types as char. Now you cannot perform division, modulo. Does this even make sense that you are performing A modulo B? So this is the reason you need to understand the concept of data type. So categories of data type, there are mainly two categories of data type: the primitive data types and the non-primitive data types. By the word primitive data types, it is self-explaining, means it is the primitive one, it's the core. Primitive data types in Java are the basic predefined data types provided by the Java language that represents simple single values such as integer, floating point numbers, characters or boolean values. Okay. Now, what does this mean? Actually, the primitive data types must be simple and single values. They can store only single values. Like you want to store multiple integer values, then you cannot use the primitive data types, and so on. They are not objects, have fixed size and memory. Actually, they are not objects and they have a fixed size. As I have told earlier, that it has fixed size and you have to know the size to utilize your resources, and after that store the actual value directly rather than the reference. And actually when you will access your data, you are not accessing through a reference, you are accessing directly from the memory. And what are those example of primitive data types? Int, float, char, boolean and more. Non-primitive data types. Non-primitive data types in Java are data types that are created by the program or provided by the Java's class library, used to store complex data or multiple values. Suppose that, as I have previously told, that suppose that you want to store multiple integer values, then you cannot use the primitive data types like integer, then you have to use the arrays, and those are the non-primitive data types. They are objects, store references to the memory locations rather than the actual values. So when you are accessing your data which is non-primitive data, then you are accessing through a reference, you are not directly accessing to your data. And what are the example is strings, arrays, class and more. And non-primitive data types are provided and can be created by the programmer and also provided by the Java class library, where where the professionals and the interested people in Java have created so much of huge libraries for us. So now let's talk about the primitive data types. First, byte, short, int and long. These four are used to store the integer data types, but their taking of storage is different. Like the byte is taking 1 byte or 8 bits, the short is taking 2 bytes or 16 bits in our memory. The int data type is taking 4 bytes or 34 bits. Long is taking 8 bytes or 64 bits. Look, these four are used to store only integer values, but they are taking different memory according to their need. Suppose that you want to store a small number, then you have to use byte short, and you want to store longer values, like when you are calculating some bigger values, you have to use the int or long, and you have to define your data type according to your need, as I have told earlier. So byte is taking 1 byte, this is simple, and 1 byte is equal to 8 bits. And now you have to look at the range, you have to remember it, but there is a formula by which you can actually get it. So what is the formula? So you have to see how much storage it is taking. The byte is taking 1 byte, that means 8 bits. You just have to remember how much byte it is taking, 1 byte, and we know that 1 byte is equal to 8 bit, and each of the bits can be either 0 or 1. So according to the permutation and combination, how much numbers can be possible from this 8 bits? 2 to the power 8. Okay, so it's mean that 256 numbers can be possible, 0 to 256. Okay, actually I don't have the writing pad, that's why actually I have less much resource. I just have a laptop and a cheap microphone with me, so sorry for that, I cannot write properly. I will buy it if you support me in the long run. So 256 number that you can store in the byte data type. Now there is negative numbers also, so divided by 2 will store equal number of negative numbers, equal number of positive numbers, then the negative and positive number problem is solved. So how much we will get? 1, 2, 8. So dividing 256 by 2 we will get 128. So 128 negative numbers, 128 positive numbers. So it is written here minus 128 to 127. So here should be 127. Why there is 127? Here should be 128. There is according to you, right? Okay. Look, see. Minus 1 to minus 128. How much number? 128 numbers. Now if I start to count from 1, positive 1, then we will be able to go till 128, but there is a number you are forgetting. It is one of the most important number, the 0. So what we are doing, by minusing it 1 from the positive number, we are getting 127, and that 1 bit is we are using it for 0. that one number is 0. That's why we are getting the range minus 128 to 0 to 127. So the range is minus 128 to minus 1, the negative ones, and 0 to 127, the positive one. Now look at short. It is taking 2 bytes. Just remember it. Short is taking 2 bytes, and we know that each byte contains 8 bits. So 2 byte 16 bits. Then what would we need to do? We would just need to write 2 to the power 16 divide by 2, because we need positive and negative numbers. So what it will get? 2 to the power 15. Sorry for this writing. So 2 to the power 15. So 2 to the power 15 negative numbers, 2 to the power 15 positive numbers. How you are getting to 15? Actually you have 1 here, and then after that you minus 16 from 1 from 16, then you will get 2 to the power 15. So 2 to the power 15 positive numbers, 2 to the power 15 negative numbers. So but as I have told earlier that you have to include 0. That's why you will minus 1 from the positive side. So the range is becoming minus 2 to the power 30, 2 to the power 15 to 2 to the power 15 minus 1. And in int also it is the same. 2 to the power int is taking 4 bytes, so that's mean 32 bits. If you divide it by 2, then you will get 2 to the power 31, 2 to the power 31 positive and 2 to the power 31 negatives, but you have to include 0. That's why you will minus 2 to the power you will minus 1 from the positive side, and it gives you the range minus 2 to the power 31 to minus 2 to the power 31 minus 1. And by long you will get the same also. Long is taking 8 bytes, means 16 bits. 8 multiplies 8, because each byte is taking 8 bits. 8 multiply 8, you are getting 16 bits. So how much number can be possible? 2 to the power 64 bits, but you have to consider the positive and negative ones. So divided by 2, you will get 2 to the power 38. So minus 2 to the power 2 to the power 63 for negative, and 2 to the power 63 for the positive, but you have to include the 0. That's why this minus 1. But floating point numbers, they're so much different, because it's also include the decimal point also. So just you need to remember that approximately 6 to 7 decimal decisions of precisions mean in float data type you can precisely calculate till 6 to 7 decimal points, means 6 to 7 numbers after the decimal point. This is the precision you are using when you will use float. Then look, first of all look and another data type, that is double. It is 15 to 16 decimal digits. Suppose that you are working with numbers, decimal numbers, where the precision is so much important, means that a single value, a single decimal point can cause a whole disaster, like the space program or whatever else. Then you have to use the double, because it is giving the more precise, and but it is also taking much more data, 8 bytes, whereas the float is taking 4 bytes. So you have to do everything in programming according to your need. It doesn't mean that he is using double in his work. You have to use that also. You have to do everything according to your need. So after that there comes the char. It is taking 2 bytes or 16 bits, and by taking 2 bytes it supports Unicode. How? Look at the calculation. 2 bytes 16 bit, 2 multiplied by 8, 16 bits. So how much combination? 2 to the power 16 combination. Here it is character. So we don't need to divide it by 2, because here in the character cannot be negative or positive. So the number is important. So the negative or positive, it is unsigned, as you can say. So 2 to the power 16 combination, and it is a huge number. How much? 65,535. It will be 36, but you have to count from 0. That's why you will get 65,535. And look, this much character you can store in Java. it's a huge benefits because you can do a I think so that 65,000 just imagine 65,000 characters that it can hold. Don't look at 535. 65,000 characters is huge. Almost almost 99% languages of their characters included can be included in 65,000 characters. So it supports almost every languages. Thus taking 2 bytes Java makes it possible to support Unicode. And Boolean, it is just one bit. 0 means false, 1 means true. So I hope so that you have understand everything about primitive data types, the range, the just only thing that you have to remember how much bytes it is taking to find the range, and for the float and double you just have to remember the precision levels when you are working with it, and Boolean it is just taking 1 bit, sorry. So the non-primitive data types. Non-primitive data types are those data types that can be created by the programmer or it is provided by the Java class library. In class library, most of the well-known programmer who are interested in Java has contributed there and made wonderful libraries for us. Like when you are storing a sentence, it like the string, you cannot use char. It can just hold one character. So how to store it? You can store it in array, but it is not good because it will take so much of time. So what is being done in Java? A string class has been provided. A string non-primitive data type is provided. Actually, string is a class. Okay, string name Dipto. It's an object. You have to access it through reference. Here you are restoring someone's name in a variable called name and you have defined it as a string. You can store multiple names here, whatever you want to store. After that there comes the arrays. As I have told you earlier that suppose that you want to store multiple integer values, then what can you do? You cannot store it in integer. You have to use the array. After that, classes and objects. I have discussed in my previous lectures what are those classes and what are those objects and how the properties of object-oriented programming is achieved by classes and objects. So you have to remember the size of the primitive data types, how much byte it is taking, and from that byte you have to calculate the bits, and from that bits you can easily calculate the range or values by using the formula that I have provided you. So hope so you will understand. And non-primitive data types are the string, array, class, object, interface, enum. We have seen object and classes. We have discussed objects and classes, how it creates, how to access the variables inside a class through an object. Everything I have done by using simple programs, but in our future lectures we are going to see string, array, interface, enum, everything. So thank you so much for your time and hope so you will support me. If you don't support me, then I will not be able to provide so much of lectures, because with so much lack of resources, providing lectures is not easy, because I don't have a keypad, I don't have just a good microphone or anything else. I just doing it with a cheap microphone and just with a laptop. So hope so that you will support me, and I will provide there may be some issues with my accent or English because I am not accustomed to it, but if you support me in the future, I will improve my everything. Then you will find it so much positive sides. So please support me. Okay, thank you so much. Hope so you will enjoy the day.